Welcome to ElectroTunes CEWP, How to Build a Hydroelectric Power Plant. Step-by-step guide. Good morning, afternoon, everyone. Today, we're diving deep into one of the most efficient and sustainable methods of generating electricity, hydroelectric power. Specifically, we're going to walk you through the process of building a hydroelectric power plant from the ground up. Whether you're an engineering student, a renewable energy enthusiast, or someone curious about the steps involved in constructing a hydropower plant, this video will cover everything you need to know. What is hydroelectric power? To begin, let's briefly touch on what hydroelectric power is. Hydroelectric power plants generate electricity by harnessing the energy of flowing water, usually from rivers or dams. It's one of the oldest and most established methods of producing electricity. In these plants, water flows through turbines, which turn mechanical energy into electrical energy via a generator. Why build a hydropower plant? Before we get into the how, let's understand the why. Hydroelectric power plants are considered one of the most environmentally friendly power generation methods. Here are some reasons why they're built. Renewable energy source, water, unlike fossil fuels, is a renewable resource. As long as rivers flow and water cycles through the environment, hydroelectric plants can continue generating power. Efficiency. Hydroelectric power plants are highly efficient, often around 90%. This means more of the energy from the water is converted into usable electricity. Long lifespan. Hydropower plants can operate for decades, typically with minimal maintenance, making them a reliable source of power. Clean and green. Hydropower is a green energy source, emitting no greenhouse gases once operational, making it a great option for reducing carbon footprints. Types of hydroelectric power plants. Hydropower plants come in different sizes and types. Let's quickly review them. Storage reservoir plants. These are the most common type. They store water in a reservoir behind a dam. When needed, the water is released to flow through turbines. Run-of-river plants. These plants use the natural flow of a river with little to no storage. Water is diverted from the river and passed through turbines. Pumped storage plants. These are used for energy storage. Water is pumped uphill during periods of low electricity demand and released to generate power during peak demand. Planning and site selection. The first step in building a hydroelectric power plant is choosing the right location. Site selection is crucial because it impacts the feasibility and efficiency of the plant. Water availability. You need a reliable and consistent water flow. The size of the river and the flow rate will dictate how much power can be generated. Topographied land around the site should be suitable for building a dam and reservoir. A higher location for the plant allows for better water pressure. Environmental impact. It's critical to assess the environmental impact. Building a dam, for instance, can disrupt local ecosystems, so thorough environmental assessments and regulatory approvals are necessary. Proximity to demand centers. Ideally, the plant should be close to power consumption areas like cities or industrial zones to minimize transmission losses. Design and construction phase. Civil engineering. The dam. The first and most visible component of a hydroelectric power plant is the dam, which stores water and creates the pressure needed. Here's how it's built. Choosing the type of dam. There are several types of dams used in hydropower plants. Gravity dams, heavy, solid dams that rely on their own weight to hold back water. Arch dams, curved dams that distribute pressure efficiently and are used in narrow canyons. Embankment dams, large, earthen dams that are built using compacted soil. Dam construction. The dam is typically constructed in stages. Excavating the riverbed and constructing a diversion channel. Building the dam wall using concrete, earth, or a combination. Installing spillways for flood control. Safety and control mechanisms. The dam needs to be equipped with safety systems such as gates, valves, and sluices to regulate water flow and ensure that the structure remains stable. The powerhouse and turbines. The powerhouse is where electricity is generated. Here's how it works. Turbines. Water flows through pipes called penstocks to the turbines, which are large blades connected to a generator. As the water hits the turbine blades, it makes them spin. There are different types of turbines: Francis, Kaplan, and Pelton, depending on the flow rate and the height difference between the water source and the turbine. Generators. The turbines are connected to generators, which convert the mechanical energy of the turbines into electrical energy. A generator works based on electromagnetic induction. When the turbine spins, it moves a rotor inside a stator, producing electricity. Powerhouse design. The powerhouse houses turbines, generators, and other equipment, and it is often located at the base of the dam or in a nearby area. It's important to ensure the design accommodates the size and needs of the turbines, maintenance, access, and electrical connections. Transmission and distribution. Once the electricity is generated, it needs to be transmitted to the grid and then distributed to consumers. Here's how the transmission and distribution works. Step-up transformer. After being generated, the electricity is sent to a step-up transformer, which increases the voltage to allow efficient long-distance transmission. Transmission and distribution. Once the electricity is generated, it needs to be transmitted to the grid and then distributed to consumers. Here's how the transmission and distribution works. Step-up transformer. After being generated, the electricity is sent to a step-up transformer, which increases the voltage to allow efficient long-distance transmission. Transmission lines. The high-voltage electricity is sent through transmission lines to substations near the area of demand. Step-down transformer. At the substation, the voltage is lowered using a step-down transformer, making it safe for consumer use. Distribution. From the substation, electricity is sent through distribution lines to homes, businesses, and industries. Environmental and social impact. Building a hydroelectric plant can have significant environmental and social impacts. Let's take a look at the key considerations. Ecosystem disruption. Damming rivers can affect aquatic life, fish migration, and overall ecosystem health. Fish ladders and other solutions may be used to help mitigate this. Resettlement. In some cases, communities living near the river may need to be resettled due to flooding caused by the dam. Governments and developers need to ensure fair compensation and relocation. Water quality. Altering the natural flow of rivers can affect water quality. Careful management is necessary to maintain good water quality downstream. Greenhouse gas emissions. While hydroelectric plants don't directly produce greenhouse gases, reservoirs can sometimes release methane due to decaying organic matter underwater. Challenges in hydropower plant construction, cost and financing. Building a hydroelectric plant is expensive. The costs include land acquisition, environmental assessments, dam construction, turbine installation, and transmission infrastructure. Time. Construction can take several years, depending on the size of the project. Climate dependency. The flow of water can be affected by seasonal changes, droughts, or floods, which impacts energy generation. Regulatory hurdles. Government regulations, permits, and compliance with environmental standards can delay or complicate projects. In conclusion, building a hydroelectric power plant is a complex and multifaceted process that requires expertise in civil engineering, electrical engineering, environmental science, and from selecting the right location to constructing the dam, installing turbines and generators, and ensuring safe transmission and distribution, each step plays a critical role in generating sustainable and reliable power. Hydroelectric power continues to be one of the most reliable and environmentally friendly sources of electricity in the world, and its role in the future of renewable energy is undeniable. As technology advances and engineering techniques improve, we'll likely see even more efficient and environmentally conscious hydroelectric plants being built around the world. Thank you for tuning in to Electro Tunes CEWP.